Welcome to Syntax. Today we've got a first of 3 shows on Promise Deep Dive. So I was driving home from dropping off my kids at school today, and I thought, like, what should we do? And I have been keeping notes on just like all of these things that surround working with promises in JavaScript, and I realized, like, man, there's actually quite a bit to working with promises and architecting them and flow control and all that. So this is going to be the next 3 Mondays are going to be all hasty treats on deep dive into promises. So today we've got sort of an introduction, understanding how promises work and awaiting them in different ways to create and listen for a promise resolve. Then second day, we're going to have one on canceling promises, helper methods, and error handling strategies. How do you specifically deal with errors in a nice way for your application with promises. And then the last one we have is getting into concurrency, queuing, flow control, fetch, canceling them, and deferreds, which is a new API in the browser. So buckle up for the next 3 weeks. We got all kinds of, I promise you are going to enjoy it.
I promise you, I was about to make that same joke.
Yes. Oh, good.
Oh, yeah.
Let's see. How many promise jokes can we make in these next 3 weeks?
And if you want to see all of the errors in your application, you'll want to check out Sentry at sentry.io/syntax. You can sign up today and get 2 months for free. Sentry is just a really incredible tool for not only tracking your performance, making sure your application has no bugs, but even just seeing what goes wrong when something goes wrong, because things go wrong all the time when we're coding. And you don't want a production application out there that, well, you have no visibility into in case something is blowing up and you might not even know it. So head on over to sentry.io/syntax. Again, we've been using this tool for a long time and it totally rules. All right. I think this is a great idea though, because, I remember when I first learned about promises back when they weren't in the browser, you had to use Q or Bluebird or one of those, right?
Yeah.
I remember being very confused about why they're a big deal. What makes them interesting? How is it different than something like a callback function? What's the deal with promises? So I think this will be a really great episode. And in this episode, and specifically, we're getting into Promises 101, creating and waiting on promises. So I think we can start this off with the first question. What is a promise, Wes?
A promise in JavaScript is an object that represents the eventual completion of some data. And that's different than a regular variable or a function return in JavaScript, because normally the result of a promise is returned immediately. You get something right away. But a promise is sort of an IOU, a promise that eventually, at some point in the future, I will give you some piece of data, or I'm going to fail, which is called rejecting. So again, a promise is a future agreement that some data will be returned to you.
It's a commitment, like a promise.
It's a commitment.
Yeah.
And I thought, let's just kick it off with just some common examples of what a promise would be. I know most people listening sort of understand what a promise would be, but let's talk about any type of data that can be returned from a promise, which is anything. The most common one being, you want to take this one?
Yeah, and I think the one that most people have used is fetch calls. If you go off and, there used to be libraries, now we have a standardized fetch API. If you go off to grab some data from anywhere, you're most likely using fetch. And if you've ever tried to access that data immediately, you'll know that it returns a promise. When you go off to do fetch, it doesn't know how long that's going to take. It says, I'm going to go get some data. I'll be right back. And then you say, all right, let me wait for that data. Or when the data does come back, or perhaps you failed to get to the store, then you can, bring that data back, and now we can do something with it. So you've gone off to a trip to the store. You've now come back with the goodies that you ordered.
Yes. And the promises being a feature of the language has been an amazing, I know most languages have sort of the idea of a promise or a way to do this type of work, but being able to have it as a primitive in the language means that you can mix and match anything that returns a promise, and you can work with them together. This is one thing when there's a new thing called deferreds that have been added to promises. And it's not really like a new thing, but it's a new API that makes working with deferreds a little bit easier. And a lot of people are like, why are they adding all this garbage? Why don't you just go and use this library that already did it really well? And often I'm in that camp, like, nah, maybe we don't need a very opinionated way to do this in the language. But with promises, being able to have a single type, previously it was, like Scott said, you have to use Bluebird or async or callbacks. It was very hard to say, all right, well, I'm going to work with this database adapter, and I'm going to be working with this API that does validation or does a bunch of queuing, and getting those to work together was always kind of frustrating. And now that we've had them in the browser for many, many years, it's much easier. Another example of promises would be a database query or an insert command. Pretty much any database ORM that you're using these days, if your database is not going to solve return immediately, and even if it did, that's something called a synchronous request or a blocking request. And what that would do is it would actually lock up the rest of your application from running. So if you, it's very hard to actually write code these days where you create a blocking circumstance, but you could, if you did have a blocking database write, you could run into the situation where your server's handling incoming requests from the user. And if you have a insert that takes 2 seconds, then all of a sudden you're blocking any requests that are coming in for 2 seconds. And that's sort of a bad day. So database queries, every ORM that you work with will return to you a promise. And then you can sort of just wait for that to successfully give you the message, say, I saved the data, or resolves to the query of the data that's been returned to you.
Yeah. If you notice a pattern here, where basically anytime something could be blocking, we use a promise, so that way it takes something that could be blocking and makes it so it does not block the execution of other things, which is one of the reasons why we have to do the whole then thing with promises that we'll get into. Another thing could be requesting a user's permissions for things like a webcam, right? The reason why these have to be returned as promises, because you're waiting for something to come back from the user's computer, whether that is prompting them to do the permissions acceptance or whatever.
And then a little wait function is an example of a promise that you might write yourself. So you might want to wait for a certain number of milliseconds. You might want to wait for somebody to click on something. You might want to wait for something to show up on the page. That's very popular in like React testing library, where you want to stop your code from running. You wait for something to show up on the page, and then when that thing is on the page, it will resolve. We'll talk about that in just a second, and you can continue on with your life. So promises have two ideas here, is that when you create a promise, you get the option to resolve that promise or reject that promise. Resolving a promise is successfully returning the data that promise has set out to go get, or to go fetch for you, or you would resolve after somebody clicks a button. That's a successful outcome of a promise is called a resolve, and a negative outcome of a promise is called a reject. And often you will call reject in your promises when something goes awry, right? That database item didn't save correctly. The user did not actually give me access to their webcam. Something happened inside of this promise where there was an error that happened because of a different library. Those are reject cases.
Yes. And I don't think this necessarily fits in there, but there's also, so you resolve or reject a promise. And those things connect very firmly to when we're working on promises. We'll talk about this in a bit, but those connect directly to the then, right? The then method is called once a promise has been resolved. The catch method gets called when something is rejected, and then finally gets called no matter what. We'll talk about those more in a second. So next up is creating promises. So how do you create your own promise? Oftentimes we're consuming promises, right? We're using a .then, we're using async await. We're not necessarily writing them, but you can write your own promises using new promise, and you can create a promise, and that gives you a callback where you can use the resolve or reject methods to, like Wes mentioned moments ago, either resolve and complete the promise or reject and fail the promise.
Yeah, you are often creating your own promises when you want to bundle together a bunch of functionality. And often you'll have like nested promises. So you might have a promise called create user, right? And in that create user promise, or a function that returns a promise, I promise I will go and create the user and return to you the actual user once I'm done. But inside of that, you may be doing several things, right? You may be doing some sort of validation. You might be checking if they have already been signed up. You might be hashing their password to store in a database. You will be actually saving that user to the database. You'll be creating timestamps. You'll be maybe creating some items that are related to that user, setting a bunch of permissions, and all of those things need to happen inside of your promise. They can also often chain them together. And then when you're successfully done, you resolve it. If there's an error anywhere along the way, you can reject that promise and say, this is explicitly what has happened. There's a new method, which I'll talk a bit more about in a future episode, this idea of deferreds. But Promise.withResolvers is another way to create a promise. And that will return to you the promise itself, but also the reject and resolve methods at a top level. And this can be handy if you want to pass the resolver and reject methods to other parts of your application rather than doing your work inside of the promise itself. And then the third way we have for creating a promise, and this is quite honestly the most common way these days, is you mark a function async. And instead of creating a new promise and putting all of your code inside of a promise callback, which does have use cases, you simply just create a function, you mark it with the keyword async in front of it. Immediately, that function changes from a function that will return you data right away, turns into a function that will return a promise that will return data at some point. And the cool thing about async functions is that inside of an async function, you can simply just return a value. You can have other promises inside of there. And if you return either a value or a promise, you don't have to use the resolve method. You simply just return. And because the function has been marked as async, it will have that. It'll work just fine. The same thing with rejecting. You don't have to explicitly reject. You can throw an error, which you might be used to already. You can say, throw new error. User email has already been registered.
Yeah. And here's a small little thing for people who find themselves doing this. If your function returns a promise, what you don't want to do is you don't want to mark the function as async and then await that promise and then return the result. You just return the promise from that function, and you're returning a promise from the function rather than having to create a new promise and do it that way. So like I mentioned, we're then going to get into like the waiting on a promise bit of this because again...
Hold on, I got one more thing to say about that. You sometimes do have async functions that return promises, and the use case for that is sometimes you want to first await something inside of that, and then you may want to return the actual promise itself from that function. There's no harm in like sort of double wrapping your promises. So if you were to have an async function that returns a promise itself, you're not going to get into any weird like nested thens that will be an issue for you.
Do you think there is any sort of performance implications there? I don't know if there is. I'm just wondering.
I don't think so. Often I have tweeted screenshots of code that I've written, and I'll just like mark a function as async, and then I'll refactor it to return a promise. And sometimes there's an unnecessary async on there, which is why I like the ESLint rule. That will be like, you didn't await anything inside of this. What are you doing marking it as async? But I don't think there is. At least I don't know of any like performance downside to having a function marked as async if you're returning a promise.
Word. All right, well, let's talk about waiting on a promise then, because like we mentioned, a promise is, it's a commitment to come back and I'm promising to go to the store and get some candy cigarettes when I come back, I better have those candy cigarettes. Do you remember those, by the way? Did you ever get those in Canada?
Yes. Yeah, it's pretty wild that we just like had cigarettes and they're like red on the tips. Like clearly you're trying to make these fake cigarettes, but
you're supposed to like keep them in your mouth. I just chomped them up. That's what I did. They're like chalky.
I can't do that.
All right. Well, let's talk about waiting on those promises, right? So the main way that a lot of people have done it is with a .then method. So instead of using async await or anything like that, you have your promise, then you say you have a function call, right? Obviously, and then you chain a .then to the end of that. .then has a callback, and in that callback has the data that's available to you if that promise is resolved correctly. Mm-hmm. If the promise rejects, you would then need to also chain a .catch. I don't know why I don't know why I said that apprehensively. You then need to chain a .catch in which the error will be available in the callback function. And then there's also a third one that a lot of people don't use, which is finally, which this will go no matter what. So if you find yourself duplicating some logic, maybe like you're waiting for a value and then you're setting a state toggle based on that value. If that state toggle is toggled no matter what, if there's an error or a success state, you could put that in your finally. So the finally is going to run no matter what after the catch and after the then.
Yeah, that's really handy if you like have like a loading state and you need to turn the loading state off in both cases, right? And after a successful return or on error, I want to turn the loading state off. The finally is super handy for that. And quite honestly, I don't see it used all that often. So
Same.
I think I should maybe start using it a little bit more myself. So the .then is a pretty common way to do it. And then we also have the ability to await promises. So when you're in a function that is marked as async, you can sort of pause that function from running. And once the promise resolves itself, you can continue ongoing. So it's a beautiful API because you can simply just say like const user equals await create user. Whereas the create user function would return a promise, putting an await in front of it will sort of unwrap the promise. It will wait for the promise to resolve and give you the actual data at the end of the day. Await also is used for generator functions, but we're not getting into that in the promise episode. So in most cases, I would say most people use the async await API simply because it reads a lot nicer. We'll talk a little bit more about error handling and how to mix and match them. There are use cases where you still want to use the .then. Chaining is a really nice one. Instead of just doing await, some people like to chain then onto one another. The other one being that sometimes you want to listen for when something is resolved, but keep the function going while you're waiting for it. So a very common use case that I've seen is you want to go off and fetch something. And then the next line below that, you want to set up like an event handler for when somebody clicks something or when a specific event happens. If you were to await that fetch request, the event handler would never run because you're essentially pausing the use case. Same thing with streams as well. That's a pretty common use case where, all right, I'm going to set up this stream and I'm going to resolve once it's actually finished. So what do you use, Scott, in most cases? Do you default to sync await?
Yeah, my default is, it is funny because sometimes it feels haphazard in which I'll be like, I'm not inside of an async function. I don't feel like making this function async, so I'll just throw a .then on there. To me, it depends on like what I have to do with that data. The thing that's always bugged me about the then methods is that you're now going another layer deep, right? Yeah. If you want to access that data outside of the promise, you have to create a variable and pass that in and worry about the default values before and after the promise return. So almost always I'm using await just because it reads more like how I would expect it to work, and then I can access the values where I want to access them. All right, wait for the value, it's there, now I can do something with it. But, there certainly are times where I am using a catch or a .then as well. I do use a .catch even on await instead of doing a try catch though.
Yeah, that's something we have coming up in the next one, which is error handling strategies of like mix and matching. I personally do that as well as I await, but I use a dot catch to catch the error in most cases. The chaining the dot thens onto each other, and I should say the way that this works is if you have a dot then, if you return another promise from that dot then, you can chain them indefinitely and put a single dot catch at the end of it to any errors that happen along the chain. Where that becomes an issue is then you have a weird scope, which is hard. And it's also really hard to like pass data between the two of them. So if you have one promise that fetches the weather and then another promise that saves the weather to the database, you find yourself having to modify functions so that they'll accept the incoming weather data. And then that's really frustrating because now if you want to comment one of them out, then you have to change the signatures again. Or you create like a variable that's outside the scope of the dot then and you sort of update it. That's annoying because now you have like an undefined variable for a short amount of time and you have TypeScript that's a bit tricky. So yeah, I like the sync await much better. The only time like I'll mix and match them is often with the dot fetch. I'll have the await whatever, and if you have to get JSON back, it's JSON. The fetch has like a double promise thing, which we'll explain in the next episode. Sometimes I'll just chain a little dot then on top of it.
Word.
But I think that's all we have for the first episode. Again, that was pretty high level of explaining promises. In the next episode, we're going to get into canceling promises, aborting promises, some of the promise helpers, which is all settled, finally, any, and race, as well as 5 different ways to handle error handling strategies.
Sick. I look forward to your promise of future episodes.
I promise it will be good. Peace.
I can't wait. Peace.